Fascinating ways to use ComfyUI. Hello my friends, how are you doing? So today I want to show you several ideas what you can do with node-based UIs like ComfyUI. In this video I show you how to install that, set everything up. I've created a zip file with an image from each of these projects, so when you drag that into your ComfyUI, you will actually have the complete network that I built with these nodes, and you can use it for yourself to experiment with that. Today we're going to go through different ideas, and a lot of them are using the concept of latent images. Now, a latent image is not an image yet. It is the kind of information that the AI understands before it is then decoded into an actual pixel image. So here you can see an example where I'm rendering an initial image and then I'm changing the ethnicity by handing the latent image down to the next rendering process. So let's look at how this process is working. So over here, right at the start, we are loading our model down here, deliberate 2 in that case, and I'm setting up an initial positive prompt, negative prompt, and up here we have an empty latent image. Now an empty latent image is just the starting noise that we are going to use, and over here this is going down here to our first sampler. Here you can see that we are using a seed. I have enabled that it uses a random seed every time. We're using 24 steps, CFG scale 7. The sampler is Euler ancestral. We are having a normal scheduler instead of Cara simple or DDIM. Then we have a denoise level of 1 here. And this goes up here from the latent output. So this outputs a latent image here, goes up into the VAE decoder. This is also using deliberate 2 as a VAE. And then this information comes in here and is decoded into a pixel image. This gives us this first image here. And as we can see from the prompt, we want to have a 25-year-old Swedish woman in casual clothing. Now, this latent output is going on into our next sampler. Now, this next sampler is also using a new positive input. It's using the same negative input, but it is using a new positive input. Now we have a 25-year-old Asian woman. I want to point out that this method, of course, is limited because we already have fully rendered the latent image here. So we can't really turn this from a night image into a day image, but changing the ethnicity is a rather small change in the image. So that works rather well. Again, we are outputting the latent image, we are sending it here into the decoder, and then this is turning into an image. Now again, we are handing this off. You can see this is going on as a latent image into the next one, and we repeat the process again with a new positive prompt here. Now we have dark black African woman. I really intensified the darkness because otherwise it's not sticking to the image, so that we actually have a black woman here. And then we again hand this over the latent image. Now in the last one we have here an Indian woman, again in casual clothing, and again it's going through the same process. So here we have an Indian looking woman. Also she has this dot here in the middle of her forehead, so that's also a very nice little detail. You have to keep in mind every time I click here, I can always generate a set of 4 pictures where the background is similar, the posing is similar, the clothing is similar, but the ethnicity is different, and that makes it actually very interesting. Now let's go here to my second example. This is kind of similar. Now in this case though, the method is different that we are using, because what I'm doing here is I'm injecting a new style into the original prompt. It's using the same idea. So we have here again our model. We have here our positive and negative prompt, and this is going into the sampler. Down here we have our latent image. So far, so good. Now this is going again into the VAE decoder, and it's creating our anime image as the first style. But I want to have the same pose, similar clothing here, but in different kinds of styles. So the first one is anime, the second one is a photo, the third one is a 3D rendering of the character. So you can see here, this is a part of a positive prompt. So we have raw photography, 8K UHD DSLR, soft lighting, high quality film grain, Fujifilm X-T3. But this is here combined, condition combining. So down here, we have our original prompt. Masterpiece, best quality woman, anime, pirate, cute clothing. We combine this original prompt with this new prompt. Both of them now together make the positive prompt. But on top of that, we are using the latent image output here as an latent image input. Instead of just noise, we already use the latent image that is rendered here, and then we decode this. And this is why we have here the same pose, the same image, but this is now a photo. Now, the same process happens down here. I'm injecting 3D model into the original prompt. I'm combining both of them, sending it into the sampler, rendering it, and then we have here our 3D model. And you can see that works really well. Now here comes the third idea. This might be a little bit confusing because I have all these similar images. Now you don't actually need this. This is just for me to show you what is going on. Now what I'm doing here is a double upscaling. So here we have our checkpoint, we have our positive and negative prompt. It's going into the sampler, it's going into the decoder. Now here, this is our original image. It has a resolution of 512 by 768. Now, as an example here, I'm using here a normal upscaler, real ESR 4 times upscale, and upscaling it over here like you would do in Automatic 1111. Now, this is the original image with the small resolution. And this now is the upscale. Now you can see that, of course, the upscale doesn't have new details in there. It's just bigger. It is nicer. It's not pixelated, but it doesn't have nice details. So the beard, for example, looks very blurry. That's not ideal. Now instead, what I'm doing here is that I'm using the latent output from our 512 by 768 image, and I'm sending it to a latent upscale. This is doubling it in size to 1024 by 1536, and this is again going into a sampler because the latent upscaler is supposed to be used in between two samplers. Now here we are again rendering with the same steps, the same prompt and negative prompt, same model, everything the same, only the latent input is an upscale, a latent upscale of our original image. This comes out from here, and here I have a decoder. You can see here, this is now the higher resolution. Now here again is the small image. And then next to it, you can see the higher resolution, and you can see that this has now more details because, as I said, a latent image is not a pixel image. So when we do a latent upscale, the AI can still add details to the image. That's really interesting. So you can see the beard, for example, has more details here. Now again, when we go back here, what I'm doing now is I'm using the image output. In this case, we are no longer using a latent image. This is the pixel image output. And this is now going into the upscaler. Now I'm using the real ESR 2 times model because we have already 2 times upscaled this. So first we have a 2 times latent upscale. Now we have a 2 times pixel upscale. And this will leave me with the same size as the 4 times upscale we did before. But now when you look at that image, you can see that it has a lot more detail and looks a lot better. Now, of course, you can do all of that in one go without these in-between steps. This is just for me to show you the steps and how they differentiate from each other. Also, here is a comparison. On the left side, we have the 4 times upscale with just the real ESR method. And then on the right side, we have the 2x latent upscale and then the 2x pixel upscale. And you can see how much better the image quality is. Now in my next experiment here, we are going to go a little bit more complex. In this case, I wanted to create different characters, but on the same background. Of course, in the same go. In this case, I only created 2 different characters, but of course you can create as many different characters as you want on the background. So I have here, of course, my model again, the positive and negative prompt for the scene. So first, I'm completely rendering the background. You can see that here as a complete image. Now I'm outputting this as an image, this time not a latent image, pixel image, down here to a VAE encoder for in-painting. Now for that we're using a VAE, which is also deliberate 2 again, and we're using a mask. Here I have created a mask with the same resolution. What I'm doing here is I have a PNG with a transparent background, and I'm deleting the parts from the image that should be masked, so this creates an alpha layer. To give me more control over the output quality and the pose, I have also used here a pose that we are decoding with OpenPose from ControlNet. So let me show you how that looks in Affinity Photo. Here we have the pose. I set the character a little bit lower so that we see the background better. And then I put over this the mask, and I deleted the parts here around the area where I expect the body to be. Now I took a very soft brush. This means that the mask can fade into the surrounding and makes it easier for the AI to melt our new character with the background. Then I turn our background off with our OpenPose puppet in here so that we have this checkerboard, and I export this as a PNG. So back in our ComfyUI, we have the mask up here with the deleted middle, and then we have down here the OpenPose image you have just seen. Now here comes the tricky part. I'm using a VAE encoder for in-paint to turn my already rendered pixel background back into a latent image. The reason why I need to do that is because I want to combine the background with the mask. So here we have the pixel input and we have the mask input I showed you before. Now this is turned with our VAE from deliberate version 2 into a latent image that I can then use in my sampler as a latent input. Now of course we also need the ControlNet image. So the way we are doing this is we have here a new positive prompt for our cyberpunk man wearing a shirt and long leather pants, 8K UHD, soft light, high quality in a cyberpunk alley at night. This is going into the conditioning for our ControlNet apply. Then we have the ControlNet loaded here for OpenPose. This is going into the ControlNet input, and we have our ControlNet pose image loaded, and we load that as an image into the image input over here. Then we also have a new negative prompt here that fits to our image that we want to use from the man, and this is all of that is going into the K sampler. So you can see we have here our conditioning from the ControlNet. This is consisting of our new positive prompt, and the ControlNet input is going into the positive prompt. We have here the negative prompt, and as I said before, the mask and our original image, the background, which has been converted into a latent image, is going into the latent image input here. And of course we are loading our model. We have here our latent output. This is then decoded again into a pixel image. So here we have our guy, and you can see on the left side we have our Ellie here with these 2 lights, and we have the exact same image here on the right side, but now we have a man in here with that pose. Now the exact same process has to happen again with additional nodes for all of the process I just showed you. And this is then of course creating the image of a woman. It's the same pose, but you can see that for all 3 images, the background here is exactly the same. If your head hasn't exploded yet, we are gonna go one step deeper. Now this method is a little bit wonky and the background is very similar but not exactly the same. But at the same time, you're getting an actual AI image that is just one image. So there's a downside, there's an upside to that. But also you find a really good example here on the ComfyUI examples. Now this is using the same method in a different way because this is combining the same background over all of the image with different characters in the foreground, while I am combining different characters with the same background in different images. Again, this is going through latent image and it's also stopping the steps of the rendering, and that is a really interesting thing to understand. So this is why I want to show you the example here. So what I'm doing here is, again, we are loading our model down here, and then we're going up here. We have our empty latent image. Then we go further up. We have another empty latent image. We have our positive prompt and the negative prompt. In this case, it's just a cyberpunk alley at night. And we have here our first sampler. Now this is the advanced sampler. And what you can see here when you look close is that we have here our start and end step. Now the complete steps are 25 steps, but we start at step 0 and we end at step 10. We have return with leftover noise enabled and also add noise enabled. Now what this is doing here is when this is rendered, we are creating this image here, and this is already the alley because when you look here, there is some yellow noise here on the side, and then there is some violet noise here in the middle and a little bit of greenish noise here on top. So when we look at our final image, you can see that these are the same qualities in here. So that means this noise already has the fundamental elements in the noise for our final image because it has already rendered for 10 steps. Now we are doing the same thing for our guy, but not for the complete image. This is why over here we have a second empty latent image. This is a smaller image. It's not 512 by 768, it's only 192 by 576. Now this is going into a second sampler. Again, this is going step 0 to 10 with the same settings otherwise. And then, of course, we have here another negative prompt. We have another positive prompt for our centered cyberpunk man wearing a shirt and long leather pants, 8K UHD, soft light, high quality in a cyberpunk alley at night. But of course, his image is just around the body. And then this has to be composed together. This is why we have here our latent composite. This is the to image and the from image. The to is the background. This is what you want to render upon. You want to render towards. The from is the image that you want to apply to that. This is where you're coming from. So because our image is smaller from the resolution, we have to push it a little bit to the side. So to the right side, we go 128 pixels, and then we have to push it a little bit lower because it's shorter. We are pushing it down 184 pixels, and we have a feathering, which means a soft edge with 48. Now these two parts, the latent composite is combining them, but both of them only have 10 steps so far. So if I decode that, what I get is this image here. But of course we need to finish that process. So what we're going to do is to use these two combined latent noises, and we put that as a latent input here for latent image for our third sampler. For that, again, we need a positive prompt. Now this positive prompt explains the complete situation. Cyberpunk man wearing a shirt and long leather pants, 8K UHD, soft lighting, high quality in a cyberpunk alley at night. This time everything is in here. And of course now what we want to do is we don't add noise, so this is disabled. We are rendering from the 10th step until the last step, altogether 25 steps. I have reduced the CFG scale a little bit, and we have return with leftover noise disabled so that no other noise is added here. And then we are ending up with this image here, where you can see that now both of these latent images, which have been combined before, are now rendered to the finish from the noise mix, basically, that we have created. Now over here we have the woman, and you can see she's a little bit off center. The character is kind of freely moved inside of that box that you're giving it. It's not as exact as with the mask or with the open pose that I showed you before in the other process. And also you can see, even though the setup of the background image is very similar, the details are still distinctly different. And also this is very interesting for experimenting with images where you do in between steps to add things to the noise. This is why this example is so interesting. You also want to check out this example here, where different characters are rendered into the same background. And as I told you, you can simply take one of the images from my zip file, drag it into the background of ComfyUI, and this will load my complete build here with everything. Of course, you still have to load here your own model. I also want to invite you to my Discord, where I have a specific ComfyUI channel. People are very active here, figuring out all kinds of cool methods to experiment with ComfyUI. And then another thing I want to tell you is that the developer of ComfyUI is inviting you to code your own nodes, to get in contact with him, so this can grow, because this is an open source project, and the more people work on it, the more amazing this project can get. Thank you very much for watching. Leave a like if you enjoyed this video, and see you soon. Bye! Oh, you're still here. So this is the end screen. There's other stuff you can watch, like this or that. It's really cool. And yeah, I hope I see you soon. Leave a like if you haven't yet. And well, yeah,